This may be a little bit different than what everybody was expecting out of this session, but we'll see how it goes. Our company began in the year 2000. We started putting gasification systems in 2003. We may not be well known to anybody in this group, but you've probably seen one of our systems. Fried poultry is on Dr. Lehman's video. It's Josh Fry's been in the world of biochar, been fairly well known. That was one of our earlier systems that was put in at fried poultry. This slide right here shows that is the feed in of our gasifier that's in a project in Ohio. That system is operating with Manure. It's operating at about 3,000 pounds an hour of in-feed. If we push that system, it will run up to 4,500 pounds an hour. This is, and the reason I put these up here, you know, one of the big issues and one of the issues I want to talk about as far as biochar is how do you go to the next level with biochar? And there's 10 jars of biochar here that we try to sell. That's 1 minute's production out of that system. So while it's nice to say I'm going to go out and sell this jar, if you're running 7 days a week, that's 450,000 minutes. So I've got to sell 4.5 million of these jars to keep one system running. So just to give you an idea of some of the challenges you have if you're trying to put in a truly commercial system. I am not really going to speak about the individual markets and opportunities and benefits of biochar. I'm going to touch on all of them, but you know, we really have not spent a lot of time focusing on one particular application. But there are 4 major areas: soil amendments, feed supplements, water filtration, and soil remediation, and odor control. There's a lot of information out there about biochar. Unfortunately, probably 98% of it is wood-based biochar. There's really not a lot out there. A lot of research has been done on manure-based biochar, and which is a real issue from our end, because typically when we go to talk to people about biochar, that's the first thing they ask. We want some data on manure-based biochar, and it's just not there. We put our first system in 2007, and I hate to tell this story, but I will. We were installing a gasifier, and there was a college professor that was watching us, and he came up and he says, "Can that thing make biochar?" And I said, "Sure it can." I said, "What the hell is biochar?" I have never heard the word before. Now, that was in 2007. The amount of information, the amount of research that's been done from 2007 to today is phenomenal. I mean, when you look at what was available at that time versus what's available now, I mean, it is just light years apart. So there is a tremendous amount of research available now that wasn't then. Biochar is a soil amendment. You know, a lot of the studies are showing, you know, there are increased plant yields. There's reduction in nutrient runoff. Because it absorbs water, there's a reduction in irrigation costs and fertilizer costs. Again, most of the studies that have been done are on wood-based biochars, but places where we have tested manure-based biochars side by side with wood-based biochars, they've done as well or better. Mostly because it brings some nutrients with it. Unfortunately, and that's the part that you have to always have the discussion with farmers. The benefits of biochar are going to vary depending on the crops, depending on the soil quality, depending on the weather. There's just so many variables that go in that. It's just very difficult to go to a farmer and just say, this is what this is going to do for you, until you actually try it on his soil and on his crops. So it makes that leap to getting people to understand this is what biochar can do for you very difficult. one of the things that is a huge opportunity from our perspective in the world of biochar is reducing nutrient runoff. I spent a couple weeks ago, I had a group from Northern Ireland that spent a week with us. They are currently prohibited putting manure on soils if a rain is forecasted within 48 hours of when they're going to apply it on soil. As of January 1, 2015, they will be prohibited from putting raw manure on the ground, period. They generate 225,000 tons a year of poultry manure. So they are looking for a solution. And we hope they choose us. But it's, it is an epidemic. The Chesapeake Bay has huge dead zones from agricultural runoff, the Gulf of Mexico, the Great Lakes. There are other contributing factors, but agricultural runoff is a big contributor to that. One of the things that we've been working on that's in progress is organic certification. Biochar from wood is certified organic. Biochar from manure is not. Biochar made from animal mortalities is certified organic, but manure is not. And I don't even try to figure that one out. But it was and really more of a misunderstanding from the regulatory agencies rather than, they accept the fact that biochar from manure is an organic product. What they have done, they have issued a prohibition because in their view it would destroy the nutrients. And quite frankly what they did, they confused incineration with gasification and pyrolysis, and it's more of an understanding and a revision of their guidelines than it is trying to get it certified from scratch. For you golfers, that is a golf green. That is a golf green that was, in the spring they had a flood and a creek overran its banks and silted the green, and they fought all summer trying to get the green to come back, and that was the green, a picture of the green taken when they, in the fall when they started their aeration process. And for those of you who don't know a whole lot about golf greens, a golf green basically sits on sand. It's probably one of the most nutrient poor soils on the planet because they try to grow grass and cut it real short on nothing but sand. They fertilize it to no end and they pour water on it, but it's basically on sand. In the spring and the fall, they run a machine across it and aerate it. They just poke holes in the sand, and then what they do, they take and put another layer of sand on top of it and drag it back and forth and put the sand back in the holes. And what they're trying to do is get some paths in that sand where it's been packed in all year long. We convinced, and we've got 2 golf courses, we convinced them to let us try. When they aerated the greens, they made the holes, and we went and spread biochar on the green before they put the sand on top of it. Now, you can remember that streak. Here's the same photo 3 weeks later. Now, there's still a dead spot there, but a lot of that green is coming back. Quite frankly, we've tried to explain to them that you're probably going to see better results from the biochar a year from now or 2 years from now after it gets some opportunity to spend some time in the soil. But it does capture the nutrients that they have. It does capture the water and retains that water and is helping the green. Last week we did another golf course, and with a green that wasn't distressed. And this is a photo 3 days after the green was treated. And the fellow that took the picture said, I've been doing this for 36 years and I've never seen a green that this shortly after aeration was in this kind of shape and was this playable. So, hopefully when you look at what are the markets for biochar and large scale markets, golf courses is a huge opportunity for us. Feed supplements. Yes.
How do you spread the jar and how fine did you make it?
It's exactly what's in these jars and what's in these little sample bags, if anybody wants a sample. That is not treated. That's exactly as it came out of the gas fire. We've done absolutely nothing to it except put it in a jar and put a tag on it and try to put a real high price on it. But all we did was put it through a regular pull behind spreader and just walked across the green. We have done some work as a feed supplement. Quite honestly, I think it's probably the most lucrative market or the biggest opportunity we're going to have for biochar. It's also going to be the most difficult one for us to develop. There is work being done in Europe. I mean, there are countries in Europe that have approved biochar as a percentage of the feed supplement for cattle and poultry. But it's biochar made from wood. There is I guess a paradigm shift we're going to have to make to get people to understand that feeding manure back to the same animal that it came out of is not a bad thing. I have a hard time when it goes through our system. It typically is in the unit for 2 hours. 2 hours at over 1,000 degrees is not going to leave a whole lot of bad things in it. So it's not really an issue, but it's a mind thing. It's getting people to overcome that. We did some work. We did some work with biochar as a poultry feed supplement. There's been studies for several years. Auburn University just studied many years ago with just straight ash, and the poultry does as well with straight ash, without the benefits of the carbon char. So there is a lot of background for this being a good beneficial feed supplement. But the main hang-up is going to be, it's going to take money and time to get FDA approvals. And as all of our natural resources get more and more difficult to obtain, rock phosphates is becoming more and more expensive. So the value of that is going to increase more and more. I had hoped that John was going to be here and speak because his discussion was about water filtration. John has done a lot of work and has sent me some of the data that he's done. And for those of you who are unfamiliar with what John's done, he has done a tremendous amount of work and the information I saw was in the Portland area. He's done a lot of work with zinc removal from all the metal roofs from the residences in Portland, and some really phenomenal. The data I looked at was like between 70 and 90% removal of the zinc in the stormwater runoff. So he's really got some good information. And I see where Dr. Lima gave a speech earlier this week. She's done some work with some of the material that was sent to her from manures and reflecting and removing copper ions from water supply. Odor control is kind of a catch-all. If you're to the point where you have no market, you can always use it for kitty litter, use it for animal bedding. It's kind of a low end usage, but it's still a valuable benefit. And I think I saw one of the other speeches in here that was 55 uses for biochar. I don't know that I brush my teeth with it. Now, all joking aside, putting it in your mouth and eating it, it's a little gritty, but I'm not too sure if you put a protein shake together, it wouldn't be okay.
I do brush my teeth with it. It works okay.
It works okay?
Yeah, with a little bit of salt in it. Given to me by a monk in Thailand.
most of you, if you've been around biochars at all, most of you are familiar with wood-based biochars. Typically, what you'll see with a wood-based biochar is you'll have a high carbon content. We've seen them as high as probably in the mid-80s, but they all should be over 60. And you'll have a very low mineral ash and little to no nutrient value, just because the wood itself doesn't have any nutrient value in it. Manure-based biochars are very different. Depending on the animal, depending on the diet, depending on how old the manure is, whether it's manure or litter, and the conditions to the inside the gasifier or the pyrolysis unit, the quality of biochar will vary. And typically what we've seen, the carbon content, we're going to be around 20%. I mean, and it's not rocket science. I mean, if you take an analysis and take out the volatiles, it's pretty easy to calculate how much, what your maximum carbon content can be, and you're not going to be much higher than that. The nutrient value, it's going to be all over the board, and it's more diet related. Egg layers are fed more calcium, so they'll have a much higher calcium content in the biochar. Cow manure, what we've seen, has got a little bit higher magnesium. Poultry typically will have the highest nutrient value. The other thing that we've seen, the nutrients that are in the biochar are in a different form, and most noticeably the phosphorus. It is more bound up. It is still available in plant root systems, but it's not in a soluble form, so it's not a substitute to runoff. So there are some additional things that happen to those nutrients, as well as just it's just being more concentrated. Now, everything I've talked about so far has been, just kind of from an educational standpoint. Here's all the things that biochar can do and the different applications. In my mind, that's not the greatest benefit of biochar. If I asked this room full of people, if I gave everybody a piece of paper and said, give me a list of the 10 most hated groups in this world, once you got past our Congress, Wall Street bankers, and probably Monsanto, you get down and most people would list CAFOs. I mean, CAFOs have got, when you go out on the street and talk to people, oh my God, we went to and I didn't go, but I had some of our group went to a green festival in DC a few weeks ago. Would you like some eco-char? Where'd it come from? Cow manure. Oh my God, no. Wouldn't even look at it. Okay, next guy comes up, this is cow manure. Okay, did it come off a CAFO? Well, of course it came off a CAFO. Anybody that thinks that we're going to feed this world and not have CAFOs is in la-la land. That's just not going to happen. When you look at a map of the United States and you look at the acreage and the amount of people we had dedicated to feeding our country in 1950, and the number of people in this country in 1950 versus where we are today, we're not going to survive without CAFOs. And people can be all high and mighty and say, well, I'm only going to buy free-range chickens, and I'm only going to buy beef that's out on the pasture. Okay, that's great. If that's all that was available, beef would be $500 a pound. And if you don't think that's true, then sit and crunch the numbers and think about it. My problem is, I think people who run CAFOs are wonderful people. I think the biggest majority of people who run CAFOs are environmentally sensitive. I think they want to be good stewards of the land. Now, we got to give them a chance to do that. Biochar is that chance. And it has the ability to reduce the greenhouse gases. it has all the attributes that we all know about biochar. But the big thing biochar does is money. If we have a market for biochar, then a CAFO has an opportunity to do something with their manure economically other than take it the shortest distance and put it on the land. I mean, there's a reason why we have saturated soils close to CAFOs. And you're not gonna put something that's 80% water and truck it halfway across this country and make money. You're not gonna stay in business. I mean, you may despise the practice, but they're not stupid. And they haul it the shortest distance because that's the only way they can stay in business. If you put in a system and you produce biochar and there is a revenue stream coming from that biochar, then that is a game changer. And for all the wonderful benefits that biochar does, if we eliminate the large volumes of manures that are being land applied, you can't make a bigger benefit. If you look at all of the environmental issues we have with our major waterways, if you gave the CAFOs an opportunity to say, okay, you don't have to land apply this, we can put it in a system, we can make biochar, we can transport it, and you solve problems. So when you look at what is the biggest benefit that it has, it is giving them that opportunity. And when you start looking at numbers, because everybody, because we've done enough of this, we're gonna put a project in, oh my God, you've gotta produce power. And I don't know about the rest of you, I've dealt with public utilities for a lot of years, because that's the industry I came out of. They're on, when everybody looks at your list, in my list, they're right below Congress. Hey, I mean, they've made my life a living hell for a lot of years. They are very difficult to deal with. You know, I've got a group that we did some work with that just put a project in, put a power project in, and he spent $1 million and a year just getting the interconnect agreement. Doesn't have anything to do with the power purchase agreement or anything else. That was just the interconnect agreement. You know, they make projects very, very difficult if you have to go to power. A 3 megawatt power project from poultry manure, if you were getting 9 cents a kilowatt hour for the power, you'll generate a little over $2 million in annual revenues. That same project, if you were getting $300 a ton for biochar, would generate $2.7 million just from biochar sales. So how important is biochar? I mean, it is a complete deal changer. And that, to me, if you're looking at what can biochar do for the world, what can biochar do for this country, that's where our efforts have been. If we have that market, if we can put those projects in, then it absolutely totally transforms the way our environment is set up. The production use of biochar, and this is not fluff. I think I read a report. I think it was Long Island Sound in 1986. They did some work, and okay, we're going to reduce the nutrient discharges into the sound. We have dead zones, and within 10 years they reversed the effect of all the runoff. So, you know, to say that, oh, that's just wishful thinking that we're going to reverse the trends in the Chesapeake Bay and the Gulf of Mexico, you know, that's a proven fact. I mean, that can be done. You know, it has to, but things have to start happening. And I'm obviously prone toward larger units, toward working with CAFOs. Everybody that's producing biochar brings a benefit to the table. My problem is if you're trying to make significant change, it's got to be on a large scale. I mean, you can't do it, you know, 5 pounds at a time, 10 pounds at a time. It's got to be thousands of tons at a time if we're going to make a huge impact. And I think, you know, it is a product that has so much opportunity. and so many different uses. You know, our issue has been, and it's the chicken or the egg. You know, I've got biochar. I'm gonna produce 3,000 tons a year. What will you pay me for this? Well, can you guarantee me you got a supply of it? No, not until you can sign me a contract. Can you sign a contract? No, I'm not even gonna talk to you until you have a supply. I mean, we've just gone round and round in circles, trying to get a market established. And that's it. I think I'll stop and see if there's any questions.
The floor for some questions. Yes, in the back.
I think you had his hand up first.
Go ahead.
This might be kind of a stupid question, but something I've always wondered about manure-based biochar systems is how would you compare that to, where is it more effective to do this instead of anaerobic digestion?
Everywhere.
I mean, and I'm not trying to be funny.
Poultry is the most ridiculous. Why would you take something that has 30% moisture content and then drown it and then have to turn around and dry it back out again? I mean, it makes no sense. Probably if I was looking at I guess flush dairies where they're already making a almost a liquid product. Like I say, I wouldn't put a digester anywhere. If I was forced to put one somewhere, that would probably be the one location because you've already got that wet. But yeah, I sure wouldn't. I wouldn't put one at all if it was me.
Yes.
I'm from Southern California, and it's a small area, has lots of horses. And recently, the state Fish and Wildlife has come in and said, guess what? You know, it doesn't rain for 8 months. The 4 months it does rain, all of your horse waste is going right down in our streams, and we don't like it. So you guys got to do something about it. Now they're exploring the gasification aspect of it, but I'm wondering, are there perhaps two things that could be done here? Perhaps a small biochar unit, and we're not talking about thousands of head of horses. We're talking, small lots, and they can condense their stuff. Could you use a small unit perhaps to turn that into biochar, or B, use biochar from somewhere else to act as a put socks, berms around their facility so that stuff if the biochar is picking up some of the nutrients that might be flowing into the water.
Well, one of the, obviously to me, what I'd like to do is, I always want to put all the manure through a gas fire. One of the things that we've done a lot of work on is blending fuels. And blending manure with wood, with walnut shells, because I know there's a lot of nut, and I don't mean nut cases, but nut farms in California. It does a couple things. It's a very high, it's a high energy fuel. Most nuts, most shells are close to 8,000 BTUs. It also is a very high, will give you a very high carbon content biochar. So when you blend the two together, you increase the carbon content of your biochar. And we were asked by a group and have done some initial work on a smaller gas fire. My problem is, this is PLC controlled. We've got a button on a control panel that the guy goes in, hits start gas fire, and that's all he's supposed to touch. It will automatically run the feed in, it will fill the bin to a level, it will shut that off and then call for fuel as it goes. It will turn the burners on, it gets the unit 900 degrees before it allows the augers to come on. The feed augers come in the top, the feed augers come out the bottom, the augers go out into the biochar. And if nothing breaks down, that operator doesn't touch another button until he's ready to hit the stop button and then empty the system. I've got a lot of money tied up in the PLC. If I make a small one, I still got a lot of money tied up in the PLC. It becomes very difficult to put a small system in and have something that's economical.
Yes.
That's just
they're putting, it's 3,000 pounds an hour.
3,000.
And it's a,
Ballpark number, what's that kind of machine go?
the gasifier itself was $1.2 million.
Yes.
So, you touched on this in a couple of the other answers. When you're dealing with cow manure, what's the moisture content of the manure, and how are you getting that to a point where you can effectively gasify it?
Well, early on, we were real proud of ourselves because we gasified material up to 60% moisture. And we really thought we were something. And what we realized is, what a pain in the neck. And when you are, and because initially we were looking at energy systems. And quite frankly, this is not an energy system. This is a biochar system with an energy byproduct.
Right.
I mean, we are focused on making biochar.
Okay.
And to make a good quality biochar, we are taking the energy off the gasifier and taking that heat, diluting it down to 600 degrees and running it through a rotary dryer, and we're drying their manure and drying it down to about 20% moisture and using that for the feed. It's a pretty good fit. They need an animal bedding, and they want an animal bedding at 20% moisture. So we control the back end temperature off the dryer. We can control the moisture content within a few percent. So we're basically preparing our fuel at the same time that we're producing our bedding. And what that does, if you run higher moisture content material into the gasifier, you have to dry the water off somewhere.
Right.
The only way you dry the water off is the energy you're taking out of the system. And typically, the higher the moisture content fuel going in, the more the fixed carbon you have to react in order to produce enough heat to drive off that water, which means that your biochar has a lower and lower carbon content. By pre-drying it and getting a lower moisture content material going in, then it allows us, basically what we've done in this system, totally different than what we did in the past. We've got 4 16-inch augers that are parallel that just feed just a wall of material through. We've got heat that is pulled over top of those augers, so we're basically pre-drying that fuel till it's bone dry inside the gasifier and starting to react to volatiles. That material is dropped over a ledge, and we've got rotating air pipes that are in a reaction zone. And then we've got augers underneath that pulling the material through. So what we're trying to do is the retention time in that reaction zone itself is very quick. Because what we're trying to do, we're trying to finish flashing off all the volatiles and get the material out away from the air before we start reacting on fixed carbons. So we leave as much carbon in the biochar as possible. You know, big difference between that and wood, because I mean, if you run the numbers, if you take all the volatiles out of wood, you'll have 90% fixed carbon.
Right.
So somebody doing a wood gasifier project that's got a lot of wiggle room, we're starting out less than 25. So for us to make a biochar that's got a 20% plus carbon, you know, we can't afford to lose any of it.
Yeah, you gotta put a real fine point on it.
So and that's again, this is our first patented technology. We've worked with 3 other technology groups before this, and quite frankly, they were all wood systems that were prostituted to run manure through it.
So all the drying, everything's happening inside this gasifier. You're taking the raw manure in, and then those first 4 augers.
No.
Okay.
No,
So you've got a third process outside somewhere.
we've got let me draw this one here. We've got a gasifier and an oxidizer. We're taking 20% moisture material in. We're coming out with biochar here. We are pulling all the syngas up through here, adding enough air, combusting it, forming CO2. We're taking 16 to 1800 degrees and putting into a big blend chamber. And then that feeds a rotary dryer. And then the exhaust air coming out of here, part of it goes up the stack, part of it goes back into here. So we're taking the two and blending this down to 600 degrees and going through the dryer.
Okay.
Now, if this same unit was on a broiler operation where you're at 30% moisture going in,
Right.
we take the material straight in. We have gotten as high as 75% moisture from their barns. It's ranged anywhere from 50 to 75%. And that's discounting the stuff that every now and then they have a busted water line they bring in, it just runs like a river when they dump it on the floor. But it's, yeah, again, we ran spent grain from a brewery. It was 70% moisture and ran it straight into the gasifier. And I mean, you can gasify it.
Right.
What happens is your retention time is so long because you have to dry the water off. Quite frankly, from an economic standpoint for a customer, it's a whole lot cheaper putting a rotary dryer in than putting an extra gasifier in. So, from pure economics, that's a much cheaper system, and from our standpoint, it's a much easier system to manage.
Right.
And when you are looking at quality biochar is our main goal, then controlling that moisture content going in is huge.
Yeah, like Tom Lyles, great presentation, really enjoyed it. Couple of comments. One, in terms of drying, a preconditioning step that we've used that will stabilize, we've used for horse bedding, is actually a rapid composting. We'll put the product both in a form and a moisture content, 20-30%, which you can manage. So that might be an alternative to a rotary dryer where you're not going to bedding, but you want to precondition the material to go into the manure. I guess another comment about the uses. I think I've worked with John Meadham and so on, we've done a lot of the stormwater stuff together, and I think there's a bigger opportunity there than we can see. And unfortunately, I understand Isabel Lima's losing her funding. I mean, she's done some great stuff in heavy metal, but we need to continue that, because I think that the stormwater application is extremely important. When it comes to the feed side, you mentioned the Auburn study. Basically, I funded the Auburn study through the Poultry Project several years ago, and we, of course, burned out all the carbon in that study and refed the ash. And when we went back to the CAFOs, the big boys, the Tysons, and so on, about making that product, their concern was not really, there wasn't a regulatory issue. Their issue was, if it can be suspected that we have dioxins in that feed going into our birds, it will hurt our meat market. So their concern was kind of outside there's another case where the technology works, but can you sell it?
Right.
Another issue they had with biochar early on, when we began working with them, and they're the same folks that have been through your shop, was how do we know that we're making a consistent product? And I think what you demonstrated with your units is that you can and do make, the birds and their diet and so on are pretty consistent bird case, and you can make a consistent product. And I think the advice of our Oregon Department of Agriculture was quite good, in that you can make a manure biochar, sell it on the soil conditioning benefits. Don't try to, the CAFOs wanted to advertise and sell and capture, monetize the fertilizer benefits.
Right.
Don't initially sell the fertilizer benefits or try to label it, but have those be the benefits and the reason why people come back and buy your char. And I think that's true of the turf market as well. So I think you got some great markets there.
So a few more questions. Yes.
Mike, I knew you had a couple projects that were in planning in the Chesapeake Bay watershed. Did they ever advance? Did they die on the
On the
nutrient
vine?
credit trading?
It's an amazing world.
Particularly the closer you get to DC.
I spent 25 years managing underground coal operations. I worked for Exxon. I worked for Quaker State. I worked for a company that bought out Shell. I worked for some of the biggest companies in the world. People who run small companies are morons. We must be. Because everybody wants to fund somebody that's big. They can't understand that a small company has people that are talented. And most of we have not had technology issues that have got projects. It's all funding issues. And typically it revolves around you're too small. And in funder speak, what that means is you're not big enough for us to sue you if it doesn't work. Because that's really, I mean, face it, that's the only thing that they're looking at. You know, it has been, and with every project we've seen, with every group that's come to us, it's all about money. And can you get the funding? Can you get the investment bankers past the fact that it has to be a 50 megawatt power project for them to fund it, which is about as dumb an idea as there is. You know, it is such a misconception of what is needed. And a lot of it's because if you look at who drives that, I mean, when you look at, if you're going to do power projects, you're going to deal with public utilities. Public utilities, quite honestly, are driven by one thing. I mean, cost control has nothing to do with their business. It's availability. As long as the lights stay on, they're in business. And I mean, and they are, I mean, they have to keep the lights on. So when they look at projects, I mean, their cost control is through the roof because they look at everything from a standpoint of how they do their business. And unfortunately, that's been the biggest problem all the way around is a farmer, a CAFO, a renewable energy project is totally different than the mindset of the people that are actually doing the funding and doing the analyzing. And until they recognize that, it's been very difficult. But yeah, we've had, right now, we've got a group in Northern Ireland that's wanting projects. We've got a group in Indiana that I think I'm gonna get one in a couple of weeks. We're talking to people in a lot of different places. A lot of people nod their head. They really struggle getting in their back pocket and getting the checkbook out. But you know, a lot of people are very, very proactive at just getting them moving.
And I have one other question that I noticed, I mean, many of the CAFOs are slurry-based operations.
Right.
So is that a sector that you avoid, or do you bring in technology to, I mean, because most of the nutrients are in the water, not in the solids themselves. So at some point, that's got to be treated.
And you know, there are technologies. I mean, we ship cow manure all over the country. And it's surprising, it really doesn't matter what moisture content they start with. They can get down to in the low 60s. I mean, you can start at 90, you can start at 75. They all get down to in the low 60s. That's an easy product to put through a rotary dryer. Okay, that's basically what we're doing now. You know, we have, it's easy to quench. Now, you can't handle all the volume, but that nutrient-rich water, you can spray that right on top of biochar and put some of those nutrients back in it. So I mean, there's a lot of things you can do. But yeah, once you get it wet, you've still got to handle it.
Yeah.
We have one more question because we have to get going. So we've been.
Yeah. What's your effective service area for getting the feedstock in there? I mean, for having a central plant like that, is where the cost of getting the material exceeds its benefit.
I mean, as far as transportation?
Yeah, transportation, getting it there to.
In a perfect world, I mean, this facility, they have 4,500 cows typically on site. So there is, I mean, all they're doing is hauling the manure from one barn directly into a storage area. So nothing's going on the highway.
Mm-hmm.
I mean, in a perfect world, that's my druthers. If you put a small centrally located system in, you know, quite honestly, you look at poultry operations, the integrators all have a processing plant clustered with houses around it because it's short distance to hauling the birds. You can do the same thing with a gasifier. Putting one that you're hauling manure 400 miles doesn't make any sense.
Last question.
Poultry litter, sounds like this mostly cow.
This one is, yes.
Okay, but poultry litter, I've heard has high arsenic content. Is that a problem with the finished product?
And for people who are still feeding arsenic, you will see some arsenic, a trace in the biochar. I think even the last few that were feeding arsenic have stopped.
Oh, really? Yeah.
I don't know that anybody's feeding arsenic anymore.
Good.
But yeah, you will see, because we did some tests and we did some work back with manure that was, when the birds were still being fed arsenic. And yeah, you could still see traces of arsenic, but quite honestly, it's below the levels that IBI set up for a certified biochar, so it's really not a lot. Thank you very much.